Okay, we are going to take a look at graphing linear inequalities. So our inequalities we want to remember was the less than, the greater than, things like that, less than or equal to, greater than or equal to. So let's review first just graphing a line. So if we're going to graph a line, say something like y equals 2x plus 1. Right? One of the easiest ways of graphing a line was we just plotted 2 points. So if I have y equals 2x plus 1, and I were to plot 2 points, let's say I'm going to put 0 in for x, and maybe a 2 in for, not y, 2 in for x. 2 different ones. So if I put a 0 in, 2 times 0 plus 1 is 1. 2 in, 2 times 2 is 4, plus 1 is 5. So there's my 2 points. That's all I need to graph my line. Here's my point 0, 1, 2, 5, and there's my line. Something like that. We also saw linear equations where the x and y were on the same side. So maybe something like this. Let's go x plus 3y equals 6. So we've seen it y equals, old slope-intercept form, and we've seen it with x and y over on the same side. So let's kind of take a look at this. We still just need 2 points. All right, so if I put a 0 in for x, and again, I usually select zeros, easy number to work with. 0 in for x, that takes this guy out. If I divide both sides by 3, y would be 2. And a lot of times when I have x and y on the same side, I can substitute 0 for x and y is usually pretty efficient. So I can put 0 in for y, and then I would be left with x equals 6. So the goal is I just need 2 points. Right, so this part should be review here, getting these 2 points. So I'm going to have 0, 2, 2, 3, 4, 5, 6, 0, something like that. Okay. And then the other linear equations we had were the horizontal and the vertical lines. These were a little bit easier to us. If I had like x equals 2, that was a vertical line at 2. I say easier because I really didn't need to go plot some points. They're a lot quicker graphs. The difficult part was more remembering what they look like, which one's horizontal, which one's vertical. Here's a horizontal one, y equals 3. So 1, 2, 3. And there's my horizontal line up at 3. So it's kind of a review there, graphing those linear equations, not inequalities, but equations. So we have horizontal, vertical. We see them in this slope-intercept form, or we see them in this standard form with x and y on the same side. Now let's go forward to now we're going to graph linear inequalities. And the way that we're going to graph them, same idea. I know it's going to be horizontal or vertical. If it's something like this, I need 2 points, and I can graph that line. Oh, our inequalities, we see 4 different ways. We see less than and greater than. We see less than or equal to, greater than or equal to. There's our 4 different inequalities. When we graph these linear inequalities, if it's less than or greater than, this is going to be what we call a dashed or a dotted line. And if I see the equal to, these are going to be a solid line. Okay? So we're going to first determine what type of line we're going to draw, dashed or dotted, or is it going to be a solid? And then we'll have to shade the region that's correct. So let's look at our easier graphs. I see easier that horizontal and vertical graph. Let's go y less than 2. Okay, so first off, pretend it's an equal sign because that tells you what you're graphing. It's going to be y equals 2. I've got a horizontal line. It's going to be a horizontal line up here at 2. And I don't see the equal to, so this means it's going to be my dashed one or dotted one. It'll look something like this. There's my line. I've used my concept of linear equations to know that it's a horizontal line. Now I move into the inequality aspect. I know it's dashed because I see just the less than. And now we're going to shade. All right, so what we also have to do is shade the region that's true. got to shade the region that's true. Y is less than 2. So where the y value is less than 2, they're either above the line or below that dotted line. And if they're going to be less than 2, they're below. So this would be my solution, that whole region. I'm going to, again, shade the region that's true. This is a line. It's split the region up into halves, top half, bottom half. One of them's true, one of them's false. We want to know where the y's are less than 2. That would be below that line, or they're less than. If I go to a vertical one, let's go x greater than or equal to 3. So we're going to have a vertical line at 3. This time I know it's a solid line, so I'm going to include that line because I see the equal to. And now where are the numbers that are greater than 3? Over on the right side. Those are the ones that are larger. X values larger than 3 over on that right. Now let's look at one where we have to actually get the 2 points. Let's go y greater than 3/2 x minus 1. We got a fraction up here. We didn't have a fraction in the previous examples. I know it's going to be a dash line. I see just the greater than. I still just need my 2 points. If I get my 2 points, I know where to put the line. So I'm doing the same thing I did previously in that I want to figure out what 2 points I'm going to use. Well, I'm going to substitute a 0 for x. Again, I'm trying to pick values that are easy for me. 3/2 times 0 is 0. Minus 1 is negative 1. So there's 1 point. 0, negative 1. Another point, when I see a fraction, a lot of times what I want to select would be the denominator. Select a 2, because the 2 going in for x will cancel with the 2 in the denominator, leaving me just a 3. So a lot of times if I use that denominator, I'm going to get some canceling going on with the fractions, makes my numbers work out a little bit easier. So again, 3/2 times 2 is just 3. Minus 1 is 2. So now I have the point 2, 2. There's my second dot. It's dashed, so we've got that dashed piece. Dashed or dotted, however you want to say it. There's what it looks like. And now I have to shade. So again, one of the 2 regions is true. The way that you can figure out when you don't have a horizontal or vertical, they're usually a little bit easier. I can test a point. I'm going to test a point not on the line. I want to find a nice, easy point, not on the line. And 0, 0 is an easy point. It's not on that dotted line. I can pick anything I want. I just don't want to be on the dotted line. So I'm going to test 0, 0. So what I'm going to do is substitute 0 for x, 0 for y, and see if I get a true or false statement. So 0 for y, 0, greater than. 3/2 times 0 is 0. 0 minus 1 is negative 1. So now the question is that true or false? Is 0 greater than negative 1 or not? And yeah, 0 is greater than negative 1, so that's true. If that's true, then that means the point 0, 0 is true, which means every point on the same side as 0, 0 is also true. So I'm going to shade towards that 0, 0. My test point gave it away. Let's go y less than or equal to negative 2x. All right, so my thought process, solid. I see the equal to. I'm going to go get 2 points, sketch my solid line. X, y. Right, if I put a 0 in for x, then I get a 0 for y. It's negative 2 times 0 is 0. I'll select a 1 for x. Negative 2 times 1 is negative 2. So I've got the point 1, negative 2, and then my solid line. Now I have to determine the shading. I'm going to shade one side versus the other and see which side's going to be true. Okay. I need to pick a test value. So my test point. Remember, the test point cannot be on the line. So this would be a situation where I can't pick 0, 0 because that's sitting on the line. I need to pick something else. Doesn't matter what, I just can't be on the line. So I'm going to test 3, 0. 3, 0 is sitting out here. Now, why did I pick 3, 0? It's not on the line. So simply, I felt like picking 3, 0. I need anything not on the line. This works. Substitute in. 0 for y. 0 is less than, if I put 3 in for x, I get negative 6. 0 is less than negative 6. So I had negative 2 times 3. Now my thought process comes in. Is that true or false? And that is false. 0 is not less than negative 6. So this is false. We're going to shade the side that's true. So if this is false, that means 3, 0 is false. That means everything on the same side as 3, 0 is false. 3, 0 was over here. That makes me shade back to that other side. I had one a minute ago where I had x and y on the same side. Let's look at something like this. X plus 2y is less than 4. All right, I know it's dashed or dotted. I see the less than. I need 2 points. I'm going for my 2 points, and I'll graph my dotted line. If I put a 0 in for x, takes this guy out. 2y is 4. That means y is 2. If I put a 0 in for y, x is 4. There's my 2 points. 0, 2, 4, 0, and a dashed or dotted line. Now I need to know which side to shade. Again, I need to test a point, not on the line. I can pick anything I want. This would be a case where I can actually go back to picking 0, 0, since 0, 0 is right here, not on the line. So I'm going to test 0, 0. That would be 0 plus 2 times 0 is still 0. So that's going to be 0 is less than 4. Okay, yeah, that's true. 0 is less than 4, which means I'm going to shade the side 0, 0 is on for those two pieces. All right, so we need to first graph the line, graph it dashed or solid, then decide which side we're going to shade. I can test a point and shade the side that's true. Now let's take a look at one that's a combination of two. Let's say I want the solution set for, get it up here, let's go, y is less than 2x plus 1 and 2x minus 3y is greater than or equal to 6. So I want the solution set. I want to know the region that satisfies both of those. So what I'm going to end up doing is graphing both of these on the same axis. So it looks like, man, that's going to be a lot of work. It's double the work of what we were just doing, but the work's not any different. So we're going to do the first one, finish that guy, and then we'll go to the second one. So we're going to take care of this first one. So we're just going to kind of pretend for a second. You're looking at, we've got to kind of pretend that guy's not there. We're just going to go do the top one. And then when we finish, we'll come back and do the bottom. So I need 2 points. Just going to kind of draw an arrow out here. Here's my 2 points. I'm going to put a 0 in for x. That gives me 1. I'll put a 1 in for x. That gives me 3. There's my 2 points. 0, 1, and 1, 3. Dashed, because I don't see the equal to. Got that piece. Now I need to decide which area I'm going to shade. So again, kind of pretending this guy's not here. I'm focused on that top one. I'm going to run a test point and decide, am I going to shade up here above or down below? And look, 0, 0 is not on there, so I can still test 0, 0. So I'd have 0 less than 2 times 0 plus 1 is 1, and that is true. So this would actually shade towards the 0, 0. Now when you're doing two lines at once, I would shade really, really light down here with a pencil or pen, really light shading, because we're going to be looking for an intersection. Since I'm up here on the board, it's kind of a pain with the marker. So what I'm going to do is just kind of do an arrow like this. Hey, I'm shading this way to remind me I'm shading that way. Okay? Because now I'm going to go to the second line. So you're either lightly shading down here or kind of draw an arrow. Hey, I'm supposed to go that way. And that'll kind of help you either way. My focus now is on this line. Right out here. I need 2 points. 0 for x. 6 divided by -3 is -2. 0, -2, there's one of them. I'm going to go 0 for y. Divide both sides by 2. That gives me a 3. So there's my second one, that 3 there. Now I'm going to go through. It's a solid line. So, let's see here. I'm going to extend this out a little bit further so I can see it crossing, but there's my line. Solid one, here's that dotted one. I've got to test a point. And this one, I can still test 0, 0. So again, I'm kind of pretending I don't see that dashed one there. 0, 0 is not on my solid one. I'm good. So I'm going to test 0, 0. 2 times 0 is 0. Minus 3 times 0 is still 0. 0 greater than or equal to 6. Wait a minute, that's false. 0 is not bigger than 6. Okay? So that means that the other way is going to be true. So I don't want to shade towards 0, 0 because I want to shade where it's true. 0, 0 is false. That means I'm now shading this way. I'm going down below here. There's where my shading is. My answer would be the intersection. My answer would be the intersection of the two. So I need to visualize that dotted line. Everything was shaded this way. Solid line, everything shaded this way. So this becomes my intersection down here. This would be my answer. Right? So I'm below the solid line and then below the dotted line right here. Right? I'll give you another example. Since I've got a couple of colors here, let's say, all right, here's my two lines again. Let's take it a dotted. And I know this isn't the exact graph, but just kind of give you an idea. Right? So on the dotted line, if I use the green, I was shading this way. All down through here, below that dotted line. And then, got a purple one here. The solid line, I was shading this way. So I'm looking for where the green and the purple combine, and that's what gave me just this section right here. So if you're using two different colors, fine. If you did, like I said, using pencil or whatever and doing a light shading, just darken in the intersection part. You don't need to go back and erase your other light shading. Just darken in the part that was the intersection, because this would be our final answer for that piece. So I can do two at once.